do whatever you want, man.
A comedy of errors.
Welcome to the Hackaday podcast. My name's Elliot Williams. I'm managing editor of Hackaday.
And I'm Tom Nardi, contributing editor at Hackaday.
This is episode 98. Today we'll be talking about China's moon rocks, Antikythera revelations, Creality versus Octoprint, and an RC Starship. Mike's out this week, so Tom has stepped into the Hackaday virtual studio to record the podcast.
I'm very happy to be here. It's always a good time.
All right, well, the craziest thing I saw happen this week was the Russian Doomsday Radios Go Missing article written up by Al Williams, where I guess it's the comms that are in some top secret airplanes that serve as temporary bases in case Russia gets nuked. I guess they were parked somewhere and got some of their top secret radios swiped out of them.
I saw the one article said they've been being repaired since 2019. And, I'm no expert in such matters. That seems like a long time to be fixing an airplane. Just to have it sitting on the ground since 2019. But
we weren't going to nuke them anyway. I mean, they could just relax.
I guess that says a lot about what their concern is on the geopolitical stage. That they're like, well, we'll just leave these things on the ground. Nothing's happening for the next year or so.
Exactly. No, it seems like a quaint Cold War relic, I guess, in a way. I totally loved Al's take on it, that if you see any Soviet radio gear at the Hamfest, you might want to think twice about buying it.
And it reminds me, there's so many stories where this old Soviet gear has just been laying around, like the Buran shuttle was just sitting in a hangar for years and years until it collapsed, and then they have the ground effect plane. I think has recently just washed up on a beach somewhere because they were towing it. And the cable broke, and they said, well, we'll figure it out later. So it just it's sitting on a beach, and I know tourists have been going and taking pictures with it. It's amazing the kind of hardware they have just floating around out there, and now their top secret security aircraft seem like they're on that list.
Hope the stuff shows up and we get good pictures of it.
That's the best case scenario for us, certainly. I don't know about the Russians, but
keep your eye out on eBay. Maybe we can get a good teardown out of it.
Definitely.
What else we got for news?
Well, just as of an hour or so ago from when we're recording this, the Chinese moon rocks have officially made it home.
All right.
Pretty big deal. So this is the first time since the Soviet Union did it in, the late 70s. There's always room for more moon rocks.
Right.
The ones we have been locked up for a long time, and not a lot of people can get access to it. Unfortunately, the reality is the same thing will probably happen with the Chinese moon rocks, because everybody wants to hold, their precious rocks to themselves. But
exactly,
at least it's getting more out there, and I think also shows that it can be done cheaper and easier than it was back then. I mean, there's nothing that really keeps a commercial entity from doing a similar return mission, and I know even NASA was talking about contracting out to some commercial groups to do landers, to do return missions. So maybe this will be the first wave in a new era of moon rocks.
Oh, that's pretty cool. Yeah, we're going to talk about this later on in the program, so let's not get
all rocked out. Yeah,
let's not get too deep into it yet. But we'll talk about it more when we get there. Shall we get down to some hacks?
Sure.
First up on my plate this week is RC Starship perfects its skydiving routine. This is a continuing project by Nicholas Rame. He's been working on vectored, rocket-esque RC propeller-driven vehicles, and this time he's mimicking the SpaceX Starship's belly flop maneuver, which is really cool. I haven't been following the Starship development as much as I should, and I got a better understanding of just what they were trying to do by watching this project. Put quickly, the Starship has these kind of wings on it, and instead of burning up fuel all the way down, once it gets into a little bit of atmosphere, it flips over on its side and uses these wings to kind of slow it down. It's not really flying, it's just kind of holding them out in the air and stabilizing itself and falling a little bit slower because it's falling sideways instead of pointy side down. And then at the last second, it flips right side up, fires the thrusters, and lands, hopefully, without exploding.
Yeah, I think falling with style is the appropriate technical term.
It doesn't look very stylish to me, but but let's be honest, it adds wind resistance.
Right, which is the main thing. The analogy is actually usually with a skydiver, where they'll hold their arms and their legs out to kind of give them a little bit of control. No one would accuse a skydiver of flying, but they can at least point themselves and orient themselves, that kind of thing. So that's the goal, especially long term. The SpaceX is hoping to send this to Mars, where the atmosphere is very thin anyway. So like traditional wings wouldn't really get you very far. So this is just to kind of get them pointed in the right direction and then use a propulsive landing in the last second.
Yeah, it's just to save a little bit of fuel on the way down, I guess, right?
Right.
Yeah, that's pretty cool. I've been watching Nicholas's project going along here. This rocket, in quotes, is actually a lot like his other rocket in that it's got two motors with propellers on them. They can rotate and vector the thrust as it goes out the back. The coolest thing about this project for me is that he's been writing his own IMU and flight controller code, and he's got that posted up as well. It's all open source if you want to do it. So if you want to build your own kind of vectored thrust rocket-like device, it's a great platform for playing around with. And now he's demonstrating that it can do kind of some other fancy tricks as well. So it looks really interesting to me.
Well, I like that he started, he's kind of mimicking SpaceX's development process too, because he started with, his little Starhopper version, which just, would hover and didn't go very high, just like the real one. When he was flying that around, like that looked like a very cool little platform in itself. Like if you're just trying to do a drone that's not the traditional quadcopter thing, it looked like a proper UFO flying around. And even if you weren't trying to mimic SpaceX's development, it looked like a pretty cool project just for that.
Yeah, no, I love these. And I love when the kind of hacker engineering mimics and really it's a smaller scale, but he nails a lot of the same dynamics that SpaceX did. And watching this video is really funny because, of course, he's got cameras pointed at the various parts of the vehicle so that he can see that it's all going right. And then I was watching the SpaceX Starship launch, and of course, they've got this multi-camera feed where they're looking at the wings to make sure they work right and everything. And it's just charming to see the exact same stuff done on this miniature scale. And, he must be tackling a lot of the same problems, just kind of the easier version of them.
Oh, yeah. Short of not having an actual rocket engine, it definitely, ticks off all the boxes. It like you said, the video of the two of them is remarkably similar, like the maneuver and everything. And you almost wonder, a big part of the real Starship test was seeing if it could actually do the vertical to horizontal transition. You almost wonder, did SpaceX just try to make a little one like this guy did and do it scaled down first?
Maybe they should have worked it out on a model first. What are they thinking? The other thing I love about this is that it's a neat problem that I think was a lot harder a while ago when we didn't have cheap IMUs and cheap gyros and cheap accelerometers and cheap fast microcontrollers and stuff. Still, it's a difficult problem to do this kind of landing upside down thing. It's basically like the inverted pendulum self-balancing robot problem, except you're thrusting into air. So it's a much laggier response. When the thing starts tipping over, you have to apply more thrust, and then it slowly kind of goes in the right direction compared to if you had wheels on the ground where you've probably got lots and lots of torque and you can right the thing right up. But they're very similar problems, and I love to see both of them. I might have to build one of these. What have you got?
I really love 3D printing with VHS tape filament, and it is exactly what it sounds like. This comes our way through a YouTube video. It's Russian, but the automatic translation is actually more than sufficient. Although it's the kind of thing you just sort of need to see. Just unspooling old VHS tapes, winding them together, sort of like yarn, pulling it through what appears to be a 3D printer hot end, sans the nozzle, and out comes a filament that you can load into whatever 3D printer you want. The final printed objects are not beautiful in the traditional sense. They have an interesting textured look, which isn't bad, honestly. It's cool if you can work it into the design. He prints out some little flower pots and that kind of thing, and it looks well. But one of the more interesting things is it's still has the properties of the tape. So it's slightly magnetic and a little bit conductive. And there's all kinds of potential applications for that. I know he talks about at the end of the video, he wants to try printing out resistors, and you could do like different length resistors would have different values and that kind of thing. And it's just a really cool reuse of VHS tapes because honestly, what else are we going to do with them?
Right.
And it is almost whimsically simple. Like when I first saw the machine, I was like, no, it can't. It must be something else. He must be treating it with something. But no, you just kind of smash it through the hot end. And, the throat of the hot end is the size of the filament, right? Because it would have to take the filament in the printer. And it just kind of works out on its own. It's almost too easy. If this was closer to April 1st, I would think it was maybe a joke.
I think there must be some real trial and error going on here. He has them taken up onto spools that are driven by stepper motors. So he's got pretty good control of the take-up speed. And I know when you're pulling real filament, when you're like manufacturing real filament, one of the keys to getting the diameter consistent is to have consistent takeoff pull and to cool it down as quickly as you can and stuff like that. That sort of stuff is probably make or break, but because these are already kind of strong tapes, like if you pulled on VHS tape, it's actually pretty strong stuff, and he's got 8 of them bundled up, so it's pretty strong. So my guess is he can pull on it pretty hard and get it through there, and he really just needs the heat to fuse it together rather than to completely melt it like you do when you're making filament from raw PLA chunks or whatever.
Yeah, and it could be that there is some room for improvement in the process, and get it a little bit smoother, and then get that final result a little cleaner. Because all those little air bubbles and stuff are what's coming out in the final product because they're popping and it's giving it like a rough surface texture. So if he could maybe smooth it out more on the way in,
I think it looks pretty cool. I know you're like picking on the like rough surface texture, but I think it looks awesome, and especially for his example is a plant potter.
Yeah, I will say it looks better than I thought it was going to look. In like the middle, he uses a 3mm filament with I think a 0.6 nozzle, and it really looked like something the dog chewed up. And I got to that point in the video, and I was like, well, at least he tried. But then he was like, maybe we could do better. We'll do it at 1.75 millimeter with a smaller nozzle, and then it's like, oh, okay, like now it looks a lot more photogenic.
I've never seen this guy's projects before, and I'm going to have to do some YouTubing later. But I will note that he showed up in the comment stream here and said he's been printing with a whole bunch of other recycled materials. He's tried out foam, DVDs, medical masks, disposable plastic dishes, etc., etc. So he's kind of working through the repertoire of garbage that you can grind up and run through 3D printers. And I just think that's awesome too.
It's like a Mr. Fusion for 3D printing. Just throw whatever you have in there and see what comes out the other side.
Yeah, so I can't wait to see what he's up to next, but really clever vid.
Absolutely.
Next up, Hacker's Discovery Changes Understanding of the Antikythera Mechanism. This is a video from Chris at ClickSpring explaining what he's been up to for the last little while. Basically, I guess 4 years ago, he started a project to rebuild the Antikythera mechanism from kind of what little we know about it. And this is an old Greek astronomical measuring device, calendar, time measuring something. Like nobody's 100% sure what it is. It was fragments of it were found and kind of reassembled, and it's at least 2,000 years old. And the game is to figure out what it does or did. And his idea was to rebuild one. And if you've seen his clock and watch building videos, he's just a phenomenal horologist. And if anyone has a good take at building this, he does. And along the way building it, he discovered an inconsistency that I guess actually a lot of other people had noticed before, but had kind of misinterpreted. And I think he might be right. The video is him making the case for one of the rings on the outside being a lunar-based calendar ring rather than a solar, normal days calendar ring. And he makes a very convincing case. We have links to a published paper that he put out that actually goes through the kind of deep statistics of why they think that the spacing between these holes on the front of this ring shows that it must be a lunar calendar rather than a solar calendar. But basically, the question is, we have about a third of the front of the face of this thing. And if you could see all of the holes around there, would it have 365 divisions? Would it have 360 divisions like a compass would? Or does it have 354 divisions like you would if you were doing a lunar calendar? Because the moon's period is 29 and a half days. And so if you kind of make a year out of that, you end up with a 354-day year.
This, first of all, it was a fascinating video, which, I mean, it's kind of, par for the course for me. But I liked that he just said, you know what, I'll just do it myself. Like, we can talk about it as long as we want. We can theorize, but I'm just going to build it with, like, period-appropriate tools and stuff, and we'll see how they actually would have put it together. And, what he talks about the 365 divisions, he says, like, that was just assumed because, sure, why not? 365 divisions. Like, and they knew
Close
that
enough.
it wasn't perfect, but they kind of just chalked that up to, like, well, back then, that's probably the best they could do. And like, these variations were just mistakes. And in him building it, he's like, no, like, you're not going to put this kind of work in and be like, I screwed up, forget about it. They'll never notice. Like, whoever did this was an absolute master of their craft, and they weren't going to phone it in. Like, you're not going to make a mistake like that. And that's the kind of thing that, when you look at it academically, you don't kind of have that appreciation. He's actually doing it. He knows how hard it is to drill all these little holes, and you're not going to, measure once and cut twice. You're going to make sure if you're going to do it, you're going to do it right. And that's the kind of thing that came with, like you said, if there was anybody who was going to do it, he's the guy.
Yeah, I think you're right. And I think it is from the kind of hands-on perspective. Let's see, to start his project, he got these ultra high resolution CAT scans of the different relics of the Antikythera mechanism. He's making a CAD from it. And what's the first thing you do? You look at all these holes and you say, well, what's the spacing in between them? And so, if you were wanting to build this thing, that's one of the things you'd start off with. And so, of course, he's doing the spacing and he's like, that's not quite right. And the distance, just so that the distance between the holes on this are 1 and a bit millimeters. And the question is, are they 1.334 millimeters, which would correspond to a normal calendar, or are they 1.375 millimeters? So, he's off in the hundredths place of a millimeter on these. But if you're doing a whole 100 of them around the ring, it accumulates up to about a 15 millimeter difference. And so I think this is what happened, is that he started to try to make this thing and then just realized it wouldn't fit, Like, the people who hadn't ever tried to make their own just look at it and they're like, it's probably about 360, 365. Apparently the Egyptians had a 30-day month. They had 12 30-day months, which gets you 360, and they just kind of added in 5 ad hoc days at the end of the year. So they had like extra leap days to go along with their calendar. If you read the papers attached to this, the first one is all kind of their statistical case for saying, look, the variance between these hole spacings is actually really small and not big enough to account for this extra 15 millimeters that you'd need to have a full solar year in here. Then the second part is him speculating about what kind of calendar the 350-something whole calendar would be, and the lunar calendar makes a good case. But then he mentions all these other cycles that people cared about back then that this calendar took into account. For instance, it could figure out when eclipses were going to happen. It kept track of the Olympic schedule, which is once every 4 years. There were a couple of these other cycles. And of course, this is all done with gears and spinning things around. And I think the killer point for this is that the year isn't 365 days. It's 365 and a quarter days. And that's why we have leap days in there as well. A similar thing works with the solar calendar, except you have to add in a leap day every like 79 years or something. The need to advance, maybe it was 76 years. Anyway, the need to advance one day every 76 years to make your solar calendar exactly line up with your lunar calendar gives you the reason to have all of these holes in that outside lunar ring. And I think that's actually a really compelling argument. If you want to get deep into the crazy calendar gearing thing, you need to look at the PDF. The video is just a teaser, but his metalworking is pretty to watch too.
So I brought this up in the comments, but we're now at the point where YouTubers are getting published, documents out there, real research, and we've come a long way from what YouTube was in the early days. This came, a few days after when they cracked the Zodiac code.
Right, for sure.
So, I mean, there's people out here, they're doing their YouTube videos and they're making real research happen and they're solving mysteries. I was really interested in a review that Al Williams wrote up over the weekend about the Creality Wi-Fi box. This was actually the first time I had heard of this. The idea is that someone at Creality said, hey, Octoprint, that really popular open source project that people are running on cheap hardware, why don't we make a closed source version that's worse and like $10 cheaper? The guy doing the review, Teaching Tech, he's very nice about it and he's very diplomatic, but the review basically doesn't work on almost any printer he tries. And at the end, he says, just get a Raspberry Pi and put Octoprint on it, which is what you should have done in the beginning, right? And I think it's a very bold move on Creality's part because, Octoprint is already so established. And I mean, you can't get far in the 3D printing community. I mean, go on Reddit and the first thing anybody's going to tell you is just get a Raspberry Pi and put Octoprint on there. It's not worth hooking up to your main computer. And then if your computer crashes or whatever, it's going to ruin your print. It just makes sense to have a dedicated machine for it. And Octoprint is so established and so respected. There's other open source projects that haven't even been able to make a dent in that space because just the momentum it has, especially when you look at the community with all the plugins and stuff. So to think that they could come in with this very janky version, actually gain any market share is kind of beyond belief. And the box only sells for, $20. So it wasn't like there's a big money to be made. You can only assume they're just trying to, get more people on their side of the fence, and because it works best with their printers. So I guess they hope if they sell these things and people look at the best printers that work with it, they'll be gravitating towards Creality machines. It's a very weird product. For me personally, the thing I thought was more interesting is that it's another little Linux box that we get to play with, and a very cheap one, not a particularly ugly one. It looks pretty cool and it has the power supply. So to that end, after seeing Al's post, I actually ordered one of these things.
Oh, good for you.
It is here with me now.
Oh,
and
cool.
in the near future, I'll have something to show for it on the site, so I can tear it down and look at it. But I mean, it is, if you're looking for a little Linux powered machine, you could do worse. I wouldn't hook it up to your 3D printer because it's not going to do that very well, but maybe if you had some other task in mind, it's worth looking at.
I really can't say anything super good about this project anyway. Like, Octoprint is marvelous, and Octoprint is basically the passion project of Gina Hoyska, who developed it herself and, has been giving tremendous support to it. I think it's good to support her effort as much as we can. And that's what kind of rubs me the wrong way about this, is that it's kind of taking something and trying to close it off into a closed niche, at the same time kind of diverting funds, resources, mind share from Gina's really good project, which is also open and has a lot of community buy-in. The printers themselves are open, but if you can control the ecosystem and control the way that you make it easiest to use the printers, then you can try to, squeeze out a couple extra bucks from the people using them. I mean, it really just puts a bad taste in my mouth.
Some people were saying they were actually giving these away with new printers on Black Friday too. So they're trying to get you
get their foot
sneak
in
it
the door.
in. Yeah, right. It's like lose money on the shaver and get it back on the blades, right? Like they'll just give you this thing to get you in their ecosystem. And honestly, I don't know what their end game is. I mean, they might eventually trying to sell 3D models through their ecosystem, because my understanding is this connects to a Thingiverse sort of thing, for lack of a better word. So maybe at some point they'll try to monetize that. Which honestly, MakerBot has completely failed to do with Thingiverse. So,
Yeah, right.
maybe that's an idea there. But, frankly, I would have rather seen Creality spend the money on Octoprint development. I mean,
Yep.
give them some money and do a customized version if you want to do that. My understanding is Prusa has a custom spin-off of Octoprint, or at least they were doing that for a while. I don't know if that's still active. Yeah, this seems misguided to me in a lot of different ways, and maybe even offensive almost if you want to take it that far, because this is only going to make things more difficult for the open source projects that are already a labor of love.
If you look at this most generously to Creality, you have to say it might be that they're making 3D prints easier for some subset of total noobs. Like, this way you don't even have to go out and get the Octopi distribution and flash it to an SD card and put it into a Raspberry Pi. All of that can be bundled with the computer for you. And so there may still be some people out there who are not as savvy and don't have Raspberry Pis just kicking around their house. And for them, maybe this will get them, some degree of that Octoprint experience for free or cheap or at extraordinarily low effort. Actually, I shouldn't talk. I didn't run Octoprint until like 3 or 4 years ago. I finally gave in and joined the modern world. I used to physically walk an SD card with the files on it over to my 3D printer in the corner there, stick it in, use that janky menu thing, go doop, 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 and then try to run it. I'm actually myself kind of a moderately recent convert to Octoprint, and so maybe it's going to pull some people like that in.
It certainly is easier, not to say Octoprint is hard to do, but I mean,
not at all. But
you open the box, you plug this thing in, and it's ready to go. It's ironic though, you do need an SD card, and it doesn't come with one.
Oh no!
All it uses it just puts temporary files and stuff on it. Like I looked, once you put the card in there, it starts like logging to it, and I imagine it probably puts like the G code and stuff on there. But I think it's interesting that they're trying to market it as this little one-stop thing, and they couldn't throw even a tiny SD card in there to make it actually functional out of the box.
Well, I look forward to you doing a teardown, a review of this thing, and maybe a teardown too. That'd be awesome to see.
Yeah, it is pretty cool. Like I said, if you're looking for a cheap little box, you could do worse. The stock firmware is quite janky, and it is very clearly like a repurposed router. In fact, if you go into the web interface, they just commented out the sections that are like router related. So when there's like the firewall page, it's just commented out of the web interface. So if you go directly to the URL for it, like you can set up the firewall, because it started its life as a little router, and they're just repurposed it as this 3D print controller. There could actually be some potential there. So clearly it's not good for controlling 3D printers, but we can find a use for it.
All right, my next hack is dead simple time domain reflectometry with just a battery and an oscilloscope. This one's a video by Alan Wolke, W2AEW, who does a lot of really great radio and analog electronics videos on YouTube, and they're always a pleasure. He's trying to do time domain reflectometry with the absolute minimum number of components, and that turns out to be a 9-volt battery and a resistor. The idea is you put a T into your oscilloscope, you hook one end up to a cable you want to know how long it is, and then the other end you have a 9-volt battery and a resistor, and you make contact with those. This sends a pulse down the cable and it comes back, and then you can use the length of time it takes for that to reflect, and that's the time domain reflectometry. You have to know the speed of electrical propagation in that cable, and then you can use that to figure out how long the cable is. This speed of propagation in the cable is known as the velocity factor, and in this video, he does a bunch of clever things that warrant you watching it, even though I just gave it away and said it's a battery and a resistor. These include, for convenience, pre-calculating the velocity factor of the cable, that is how fast the electrical signal propagates, in terms of like feet per nanosecond. Why nanoseconds? Because that's what your oscilloscope's going to read. So you can just kind of read off the scale in the x direction over time on your oscilloscope and just multiply that by this number, and you know how long the cable is. It was also really funny because he's like measuring a spool of Cat5, and he figures out that it's about 90 feet long. And then he looks at the cable, and it has on the shielding on the cable how much more cable is left on the spool. And so he pulls it out, and of course there it says 90 feet. And so, winner, he was right. I didn't know that Cat5 cable was marked how much you have left on the spool. That's really...
Yeah, I want to start looking at mine to see if I have any.
That's a brilliant tip. I'm going to look at all the cable running around our house.
So first of all, it sounds like big science, right? It sounds like something,
right?
And I think Dan mentions that. I think in the write up, it sounds like something that's very hard to do. But this video, makes it very approachable. It's a practical thing, if you had some kind of unknown run and you wanted to see how long. I mean, this is not something that it's unreasonable to think we'd run into, right? If you had some installed wire. But I think the best part for me was just how phenomenal this video was. I mean, everybody has a different opinion, right? But like, to me, this is peak YouTube. This is a guy who knows what he's talking about. He shows you. There's no music. No one told me to, click that bell and get subscribed. I mean, I hate what YouTube has become. And I think probably that's not, a hot take anymore. I think a lot of people agree with that. Like, it's so overproduced anymore, a lot of these channels. And this was just what I go to YouTube for. Like, somebody who knows what they're talking about and can convey that to me was just perfect. Even if I was never interested in this technique, it was just a joy to watch the video and listen to him explain it.
Yeah, and I've looked at some of his older takes on time domain reflectometry. Basically, he was worried about how sharp a peak you can put down the wire. Like, if you want to make a really quick pulse, you can see the pulse rise and fall time, and then the reflected signal will also be a pulse. And so you can use the distance between these pulse trains. In this case, he's just connecting it with a battery, and so it's not a pulse, it's a step. And he's using then the difference in time between these steps, and so the voltage adds up. But that actually opens up a couple new cool things that he points out in this video. Besides making everything infinitely simpler, it also gives you a step of one size and then a step of the other size, and you can use that to figure out what the characteristic impedance of the cable is. And in particular, if you get the step sizes to match, you know that the characteristic impedance of the cable is the same as whatever resistor value you're using to tap on your 9-volt battery. Right. And so you can, if you've got like a stack of 50 ohm, 100 ohm, 75 ohm resistors, you can try to figure out what the cable's characteristic impedance is. And the other thing he does is he does it with things that I don't think of as cables. In principle, this should only work with coaxial cables because you need the electrical wave propagating down between the live central wire and the outer neutral sheath, and then it bounces back. So it's like a waveguide, basically. So you absolutely can't do it with single conductor wire. The reason it works with Cat5 is because those twisted pairs are tightly twisted to each other, and so there's always this kind of mutual capacitance between them. But he does it with zip wire from like old speaker wire, and a couple other things. It's really neat to see him like really chasing down all of the neat things that there are to know about this particular subject. And it really is just get a fast digital oscilloscope, a battery, and a resistor.
If only it was always that easy, right? This one comes our way from Timon. The Pi compute module is a love child of Raspberry Pi and Arduino. The idea here is he's created a custom board for the compute module 4 that more or less looks like an Arduino. You have the rows of headers on the side and all the important bits on one end. And it's don't get me wrong, it's a cool little dev board, and I'm sure there'll be plenty of people who are interested in it. I think he's already talking about selling them or getting them produced. I think he said that on Twitter. But I think the coolest thing to me is this is just another one in a pretty impressive array of Compute Module 4 boards that we're seeing already. And honestly, I didn't expect to see this many or have them show up so quickly. The new Compute module has a different interface, and it looked quite scary to me, to be honest, when I first saw it. And I said, nobody's gonna. We never really saw a lot for the Compute module 3. I mean, there was a couple projects here and there, but it was sort of bespoke stuff. You want to put a Compute module in a Game Boy, so they made a Game Boy motherboard for it, something like that. But we seem to be seeing a lot more for the Compute module 4, even though there is a higher difficulty level. I don't know if that's just because the Compute module 4 is a more interesting platform, which I think you could argue it is, right? You got certainly more powerful anyway. So maybe it finally was what it took to get somebody to be interested, or maybe the state of homebrew PCBs is better. I don't know what the X factor is, but it's interesting to see how it's playing out.
Yeah, I really love this board. I actually teased Timon about it a little bit. I was like, is this a bar bet? Were you drunk? Like, what happened here? This is what happens when really smart people have crazy, silly ideas. It's like, I'll take the fastest, brand newest Raspberry Pi and I'll wedge it into an Arduino form factor so that people can use the GPIOs to blink LEDs or something. I mean... No, I'm being mean. This is actually a great idea, and it makes it accessible. I don't particularly like the Arduino Uno form factor at all, but it happens to be what a lot of people are making shields for, and I use it for motor drivers because there are some dirt cheap Chinese stepper motor driver boards out there that just plug right into an Uno, and so, flash Gerbil onto the Uno and boom, you've got 3-axis, 4-axis motor control like that. Like, that kind of convenience is totally worth something, and it's really kind of cool to put some extra processing power into it. It also breaks some of the stuff out that you might be interested in, like the HDMI and a USB port, so you can actually make this into like a real computer. I scoffed at this at first, but I would be one of the first people to plug, for instance, a motor driver shield into this thing, and then you've got the Linux computer talking directly to the stepper motor drivers, and you're good to go. There might be hard real-time problems with that. I might go step back off that. I might have to delete that.
You're definitely right, though, that it puts the Compute module in a form factor that you could probably argue is more useful than the Pi 4 itself. I know a lot of people have complained about you have the weird 90-degree angle port situation on the Pi where you have, power on one side and Ethernet on the other. And it makes it weird to work it into like a set-top box and stuff. You'll see these little cases that look like a Super Nintendo or whatever. Sure. They always have to work around the fact that half the ports are on one side. And I can't imagine why they decided on that originally, but this fixes that issue and it puts everything on one side. So there are people who just on that would go for this over the traditional Pi 4. It would certainly be easier to implement into a CyberDeck or whatever gadget you're building because you don't have to deal with that weird geometry.
Fair enough. My favorite comment here is, this is the first time I have a sense of the Compute module even without a banana for scale. This is WF's comment. I just love the idea of Arduino board for scale. Is it bigger than an Arduino? No, it's smaller than an Arduino.
Well, like you said, there's such a big installed user base for the shields and everything. So people, certainly in our community, knows how big that is. So this kind of...
Yeah, I love that Timon put out a carrier board for this. I'll throw the link for that in the show notes. Easy carrier board for the Compute Module 4. This was his first project, and he must have done that in the first week that they came out. And he just, ran the lines out to, an HDMI plug and a whatever USB plug, and just kind of demonstrated how easy it was to do. And this was on a board that he routed in an other mill. So it wasn't even like high pitch etching anything. It's just kind of the quickest, fastest thing he could do, and it all works. So I thought that was really inspiring, because I actually got given preview versions of the CM4 and went through it all and was like, this would be pretty easy to make a breakout board for. Because honestly, all you need to do is hook up power and ground to the thing, and it's got Wi-Fi on it, right? Then you've got a headless Linux box with just, 2 lines. If you want to break out USB and all the rest, then, you've got a little work to do. But that stuff is not any worse than running, maybe impedance controlled traces. Although Timon shows that the strict impedance control isn't even that necessary either. Like, even the HDMI works fine with his kind of rough and ready breakout. But then this is taking that to the next level and making something that's kind of a really cute project that I joke that it's a bar bet. But then as soon as he puts this out, everybody's like, that's exactly what I wanted. So
yeah, I didn't know it, but now I want it.
Boom. Kudos to you, man. My first quick hack this week is a video from Techmoan, Tunes You Can Eat. He basically found out that you could get chocolate records pressed and did so. It's not that interesting, except it reminded me of Ben Krasnow's attempts in his Applied Science channel to make chocolate diffraction gratings, which are infinitely higher resolution. Basically, chocolate is fantastic for molding with, and if you can make records and you can make diffraction gratings, I wonder what else you can make. Next up, Trammell Hudson's a 3D to 2D converter to make plots from STLs. This is lovely. He's got the Stanford bunny drawn out by a 2D plotter robot. Plotters are awesome, but what will you feed them for input? Nothing looks better than the kind of distorted triangles of an STL. And Trammell just wanted to play around with the STL file format, and so he wrote himself a 3D to 2D converter. He did it just to scratch an itch, but there it is on the internet. You can play with it, and looks like it's really fun to make things to feed to your plot bots. Last up, RC over LoRa for when things really go south. This is a distributed project by Cell Soul, and it's led by Spirit Plumber in the Hackaday comments. I love this. It's an IRC over LoRa gateway, basically. Each little node is as easy as an ESP32 plus LoRa radio device. You just flash your code onto there. They serve as repeaters, sending text messages between them. You can also hook them up to the internet so that they can connect to IRC by default. This provides little Wi-Fi access points everywhere that are connected to each other over the LoRa backhaul. The idea here is for a disaster situation, when the internet goes down, at least you'll be able to communicate this way. I just think it's awesome when hackers build out their own infrastructure just for the fun of doing it.
My first quick hack is Little Red Nightlight is just right. This is from Vic Cheney. On the surface, it's about as simple as it can get. It's a red LED, a resistor, a couple of batteries. It's, the idea is you hit this when you're going to the bathroom in the middle of the night, and the red light keeps you from losing your night vision. But it's easy to dismiss because of that. When you really look at it, there's a lot of awesome details. He makes his own battery contacts. He 3D prints this really clever eyeball kind of light thing that you can point it around. And it just kind of shows that sometimes the details are really the best part of the hack, even if the overall thing's pretty simple. My next quick hack is Slick DIY Compound Bow uses coiled springs, toothbrush heads. And that is not a typo. It really uses little toothbrush heads. This one is by Zunder. And the thing I like about this is it looks like something that you would fight off raiders in some kind of post-apocalyptic scenario. It's definitely made out of, I think those are like parts from a bed maybe, and a couple 3D printed parts. The end result is a really effective compound bow that he shows us some target practice with it. The nice thing, other than looking really cool and, you could do some damage with it, it's also very easy to understand. The traditional compound bow is sort of a mysterious looking thing. But the way he breaks it down and shows how everything works, it seems all suddenly very approachable to build your own bow in the backyard should you have the need. For my last quick hack, I have Real Hackers Video Conference in Terminal. This one is by Andy Kong, and his friends were upset with the Zoom culture that we're all in right now and didn't like the possible security implications and all that. So they decided to make their own secure solution. And this is a perfect example of security via obscurity, because it's secure because no one else would ever go through all the hoops required to run their own server. The idea is that your video is compressed by turning it into ASCII art, and that is then sent over and will show up in your Linux terminal. You could try to run this on your own. The instructions are there, and once we figure it out, I think we're going to use it internally for all the Hackaday video meetings. But even if you just watch the video, it looks basically what you might think like the Matrix looks like, with all these falling characters, and it makes me wish that I could buy a webcam that looked like this all the time.
All right, that brings us to our can't miss articles this week. These are articles written by our fantastic Hackaday writers. And the first one I'm picking this week is by Tom Nardi. It's China's moon mission was about more than rocks. And Tom is kind of our resident space geek, right? Is that fair?
I think it's fair. That's what they called me all through school, too, so it applies.
If it's true, it's true. We talked at the beginning of the show about the Chang'e 5 lander coming back and bringing its rock sample to Earth. Tom, your take on this in the article is really great. Let's see, the Chinese lander is doing this kind of multi-stage mission. They're not just going there with a rocket, grabbing stuff and rocketing back. Instead, they are doing the whole command module that orbits around the moon, dropping something to the moon that picks it up, transfers to a lighter launch vehicle that then goes up, rendezvous with the orbiter, and then launches that back to the Earth. If that sounds a lot like the Apollo missions to you, it's because it basically is. And I think your take on this, Tom, that this is actually kind of practicing for more intricate and more demanding, heavier, I don't know what missions, is a really great one, because they've got this problem that they got to test out here, which is, can we do a robotic docking in orbit around the moon? And they've got some moon rocks home, sure, but they've demonstrated that they can.
Yeah, getting to the moon and picking rocks up and taking them home is not easy by any stretch of the imagination. But even still, they did this on hard mode. You know what I mean?
Yeah.
They went way beyond what was strictly necessary, because, the Soviet Union showed that it was possible, even with 70s technology, to just drop there with a little simple lander and shoot a canister back off. You didn't need that intermediary, orbital module. But you almost certainly need that if you're going to send people. So the fact that they took the long way around, I think it's no secret that this is sort of a dry run. They want to perfect this technology now before they have to put people in harm's way. And we didn't have the luxury during the Apollo program to do that. They had to test these techniques in low Earth orbit. There was no way. I mean, they could have sent them to the moon, but if something had gone wrong, obviously it would have been a lot harder to get them back. So they did the Gemini program, which was, if you look at it, was really just about how do you navigate in space, how do you dock with something, how do you get out of the capsule, all the stuff that would be necessary to do a full-fledged moon mission. If China can replicate some of that with their robotic missions, they could potentially save themselves a lot of time and money, not to mention risk to human life, when they eventually go to the moon, with astronauts, which has always been their intention. They've never been shy about that. They hope by the 2030s to have, if not an outpost, at least a landing, a boots on the ground, flag waving kind of mission. So this could be a big advantage for them. And the fact remains that they now have more practical hands-on knowledge about how to navigate and operate in lunar orbit than the United States did before they sent people out there. The remote technology wasn't where it needed to be for that kind of thing. So whether or not it changes their plans, or, you know, if their human plans look different than what it did in the 60s, that's yet to be seen. But there's no question that they now know more. And, you know, knowledge is always nice to have when you're sending people out on extremely dangerous space missions.
Yeah, I guess I don't think about these things, but of course you had to practice all of this. And of course, when it was, a new frontier to dock two vehicles together in orbit, it's strange for me, right? Because I'm born after this time to think of that as being an impossibility. But like you said, that was the whole point of the Gemini program, was to try to get two things to dock together in outer space. And I also thought it was really cool that you brought up that they'd been doing practices for this robotic rendezvous here in Earth orbit first, before they have to do it in, one step further hard out on the other side of the moon, and etc. This kind of incremental progress. Can we build ships that do this? Can we get this milestone done? Can we get this milestone done? Makes it almost seem kind of plausible in a way that somehow the space stuff didn't seem to me as a not such a space geek before. So I really appreciated that part of this article.
There's a lot of cool little details. There's only so much space you can put in it when you're writing this kind of thing up. I think one of the real neat things is that when they brought the sample up, so there's the lander collected the sample, it put it in the little ascent capsule, which incidentally, it's hard to say, the Chinese are not super sherry when it comes to this kind of thing, but it's theorized, my understanding is that the ascent capsule is actually the smallest and lightest object to ever take off from another body and reach orbit. Like I said, we don't know exactly, because I don't think exact details haven't been published, but just by the pictures and stuff, it appears to be. When they went back into orbit and they docked with the waiting command module, for lack of a better term, they actually had to transfer the samples. So they docked, and their two little hatches opened, and this little sample thing on rails moved through open space from one craft to the other, and then the hatches closed, and there's like this really cool video of that happening. So there's a lot of little intricate maneuvers that were tested here, which had never been done before. So when I wrote that, it was still last week, so there was still a possibility that something could happen. You can always burn up in the atmosphere. Who knows? But I said that even if they don't get the samples back, there were so many firsts that this was going to be a huge success no matter what. They came away with so much more knowledge and practical hands-on experience that they would be in a perfect position for the next mission, which is going to be a carbon copy of this one. It was actually, the next mission actually was the backup. If this one had failed, they had backup hardware ready to roll. Now they see that it works, so in theory, no changes are required other than maybe whatever software tweaks they picked up, and they're going to run that again. So it'll be another dry run, and then it'll be interesting to see where they go from there. What the next generation of their robotic missions will look like before they actually send astronauts.
Right on. Well, thanks for keeping your eyes out for it. We'll look forward to reading up what's going on with the rocks that did make it to the ground, and whatever's going on with the next mission when it does happen.
Yeah, absolutely. My pick this week is Peeking Inside a VW Gearbox Reveals Die Casting Truths by Lewin Day. This was a really cool look at something that, by design, most of us will never see. Lewin got his hands on a free Volkswagen. The only problem was the automatic transmission was shot. Now, I am no stranger to getting my hands dirty and opening the hood from time to time, but I've never been in a position where I thought, I'll just open this automatic transmission and see what's going on inside of it. So reading this, if nothing else, showed me how far Lewin is on another plane of existence in terms of DIY mechanic work. So he opens the transmission and he's poking around, and I don't know that he ever actually says what was wrong with the transmission. If I open it, I know exactly what's wrong with it. It's been opened and I've destroyed it.
Never going back together is what's wrong with it.
I've lost something, and it will never ever go back together and get this thing off my property. But while he's in there looking around, he notices all these little surface imperfections. And if you were not Lewin Day, you might just think, whatever, that's what it's supposed to look like. But he has the practical experience to know that what we're actually seeing are defects in the production. If it was any other part, if it was something that you would see on the outside, they probably would have been rejected, or they would have, cleaned them up or whatever. But this is something that is like in a fluid reservoir. So no one would ever see these little, I don't even know what to call them, little cracks and extra material. So rather than waste the time and money, they said, screw it. Just close it up and fill it full of fluid, and it'll very likely never see the light of day again. In seeing these different defects, he kind of walks us through the production, right? Because to know why you're seeing these problems, you have to sort of know how they make these parts. And it's really just a fascinating look at how these aluminum parts are molded and the kind of machinery that goes into it. Lewin concludes that this was obviously a cost-saving measure, because you don't want to throw these dies out just because they're making rough-looking parts when no one's going to see the part anyway. So it's kind of an interesting behind-the-scenes look at the little tips and tricks that are used for this kind of scale manufacturing, where you can eke out a little bit more usage here and there just based on what the part's going to be used for.
Yeah, this was like the perfect storm for Lewin, because he's A, kind of our gearhead, and B, he is a former casting engineer. So like he was doing this for his day job, and when he opens up car parts and he sees these little nubbies and these casting lines and these little blobbies that are left over from the pits from where the dies that these were cast into had been pitted from excessive use, he knows exactly what he's looking at. And I love that. It's the kind of thing that, makes sense after you see it. I would have had no idea, because I don't have these kind of combinations of expertises that Lewin happens to have. And I just love it when we get these kind of articles coming out of our original content.
If I'm honest, even though he's gone through the trouble and like circled them in big red highlighter here, I still kind of like struggle sometimes just to see what exactly, I certainly wouldn't have noticed it on my own. But even when he points it out, I'm like, oh, okay, I guess.
It's nice to see him, looking into what all these defects look like. As long as they don't matter, they don't matter. And it doesn't bother me at all. But it does give you this like inside view.
I've seen like AVE on YouTube has done teardowns of tools. And I remember a couple of videos where he points out similar stuff in the plastic injection molded cases. And he kind of makes the same conclusion, that they're running the dies way beyond they probably should, because that's money. You want to print out, push out as many of these drill casings as you can before you have to, make new dies. And he even points out sometimes where you can see repairs were made. I don't think Lewin ran into that necessarily. Maybe you can't, it's probably a difference between plastic and metal injection molding, but he can point out where like you can see the die has been repaired and filled in and that sort of thing, because just trying to keep them as running as long as possible, keep pumping these parts out until the thing just falls apart, and then finally you have to get another die made. But hopefully by that point you've redesigned the part and always forward with something else, right?
And that wraps up this week's episode of the Hackaday podcast. Thanks for listening. As always, the show notes are available at hackaday/podcasts. You can reach us, editor@hackaday.com. Your tips are the best. We can't do it without you. tips@hackaday.com. And until next week,
keep on hacking.
I have to say all Mike's things. Your tips are our lifeblood. First swap this. I'll just do it twice and I'll.
Oh, I've done it again.
I do that 17 times. Like I'm here babbling right now. Like there's no tomorrow.
All right. What am I doing here? How do I put this? Measure. Yeah, that's the English. Yeah, sure.
Deep breath. Antikythera.